Alrighty, so we have 5.7, which is solving quadratic equations by completing the square. So our objective is just that. So we are going to solve quadratic equations by completing the square. So we've learned how to solve quadratic equations by factoring. You do have to, like, when you go to factor, usually you would have that linear term. We solved equations by square roots, where you only had a constant and a quadratic term. So solving quadratic equations by completing the square, this is a method where you would have all three terms. You would have your quadratic, linear, and constant term. Okay, so we get a problem like x squared plus 10x plus 14 equals 25. Now, some of us might say, well, you know, I mean, I could just factor that, like get it all set to 0, blah, blah, blah. And that's fine and dandy, but you do need to understand this method of solving. This is actually going to come up, completing the square really comes up in pre-calculus and or college algebra, and so that's why I think it's important that we preview it. So the first thing is, anytime you're completing the square, unlike solving by factoring where you want to set the equation equal to 0, you actually want to make sure you just have your quadratic and linear term on one side and your constant on the other. And so I'm going to go ahead and subtract 14. So I have x squared plus 10x, and that equals 11. Okay, then what I want you to kind of think back, you know, remember when I said, like, oh, this is a perfect square trinomial. You don't really need to know just looking at it that it is, but understand what a perfect square trinomial is and all that stuff. Well, what we're going to actually do is we're going to take this binomial of x squared plus 10x, and we're going to make it into a perfect square trinomial. And let me show you how you do that. So, you first, you know, you have your quadratic term, you have your linear term, plus, and then I'm going to have a blank. And then I'm going to have an 11 plus a blank. Okay? This x is bothering me. Let me fix that. So the thing is, in order to make this binomial of x squared plus 10x into a perfect square trinomial, I am going to have to, like, add the constant term to make it a perfect square trinomial. Because I'm going to do that, whatever you do to one side of the equation, you have to do to the other. So whatever I'm going to add here in that space, I also need to add on the right side of the equation. Now, what you actually do in this spot here is you actually take your b value, or your linear term, and divide it by 2 and square it. Okay, so I'm going to take 10, I'm going to divide it by 2, and I'm going to square it. And that's what I'm going to have over on this side. Okay, so it's always b divided by 2 squared. Okay, and so let me actually write that. So I've got x squared plus 10x plus my 10 over 2 squared equals 11 plus my 10 over 2 squared. Okay, so now I'm going to actually do 10 divided by 2, which is 5, and 5 squared is 25. And then I've got 11 plus 25. So all I did was actually calculate that. So now the next thing that I do is now I have a perfect square trinomial. Okay? Because I did b divided by 2 squared to get my constant term, and that constant term then is, then that actually does create that perfect square trinomial. So then what I'm going to do is I'm going to take the square root of my quadratic term. So the square root of x squared is just x. I'm going to take the sign of my linear term, which is positive, and I'm going to take the square root of 25, which is 5. Okay? And so then that is x plus 5 squared. Okay? Because basically, what you can think about it is, is I factored my perfect square trinomial. But if you already know it's a perfect square trinomial, you can kind of use that shortcut. So again, the shortcut is square root the first term, take the sign of your linear term, and square root the constant term, okay? Now I'm going to have 11 plus 25, which is 36. So my goal is to find out what x is. That's the whole point of this, is to solve for x, and I need to figure out what x is. So this whole thing is squared. So in order to solve for x, I'm going to have to take the square root. So I'm going to take the square root of x, the quantity of x plus 5 squared. So all that does is remove the square. So now I have x plus 5. And that's going to equal, now the square root of 36, remember, is 6 and negative 6. So what I actually have to do is I have to take this x plus 5 and I have to set it equal to 6. And I have to set it equal to negative 6. I have to set it equal to both the positive and negative 6, because that is the solution when you take the square root of 36. And so now I am going to subtract 5, and I get x equals 1. And here I'll subtract 5, and I get x equals negative 11. So those are my two solutions. So again, could you, could you solve this by factoring? Sure, you could. But it's important to understand how to complete the square and to be able to solve doing so, just again because you will revisit this concept of completing the square in pre-calculus, okay? I'm actually going to finish this video out here. I have 2 more example problems for you for when it's not so perfect of a perfect square that we end up with, so that way you can see that. So you'll see that in the next video, those 2 problems, because I won't have to explain as much in the next 2 problems.